All right, these are trigonometric equations, but they're quadratic in form now. So if you look at this, this is really 2, and then the cosine x squared minus 1 equals 0. Remember, so that square here just means we're squaring the cosine. So if we take that cosine x and replace it with a, it gives us this. And then this is now our square root property. So the first thing we have to do is to isolate that a squared. So we move the 1 over, and then we divide by 2. And we end up with a squared equals a half. And then continuing to solve. So if you remember, we have two answers here. And with our square, we're going to get that plus or minus. So that's where our plus or minus goes. So we end up with plus or minus square root of 1 over square root of 2. So remember, we want to separate them so that we can rationalize. And that gives us our plus or minus square root of 2 over 2. So now we can get our answer. So cosine x was our a, and that equals the square root of 2 over 2. And then the cosine x is also equal to negative square root of 2 over 2. So we're getting two different equations off of here. That's what happens here. Okay, so now we just have to find out what the angles are that match that. So let's open our unit circle. We need square root of 2 over 2. And remember, cosine is x, so it's here and here. So pi over 4 and 7 pi over 4. So our x would be pi over 4, 7 pi over 4. And then we also need the negative. So right here, negative square root of 2 over 2. So 3 pi over 4 and 5 pi over 4. So these are our answers, all four angles. All right, let's try another. So now with cosecant, we do the same thing. We would now say a is equal to cosecant, and we would solve. So a squared minus 4 equals 0. Solving for this, we get a squared equals 4, square root. So a equals plus or minus 2. And then we rewrite it back in there. So cosecant x is equal to 2, and cosecant x is equal to negative 2. Cosecant is a reciprocal of sine. So we then write sine x and we flip it. And we flip it. So now we just need to look at our unit circle and see when does sine equal a half and negative 1/2. So again, sine is the y, so it's equal to a half here, a half here, and then a negative half here, and a negative half here. So it's the 30 degrees that we have to look at. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. But just to keep it even, we'll do the pi over 6 and 5 pi over 6 for the first one. And then the two negatives. So negative 1/2 would be 7 pi over 6, and negative 1/2 is 11 pi over 6. All right, so let's double check them. See, there's a 7, the 11, the pi, and the 5. There are your answers. So this was square root property. These first two are using square root property. And so we have next is the factoring and quadratic formula. So here our value is sine. That's our trig ratio. So this would give us 2a squared minus a minus 1. And the first thing you want to do is, number 1, try to see if you can factor. Number 2, quadratic. But on each of them, they have to be equal to 0. So when you see that a squared and then a matching a to it, we want to try and factor it. So what two numbers and multiply it? And when added, so we get 2a, So if I put a -1 here and a +1 here, we would get 2a squared minus 2a plus a, that's minus a, and minus 1. So now we can say 2a plus 1 equals 0, a minus 1 equals 0, so a equals 1. And then we just solve. And there they are. So now we can rewrite them. So this means now, because a is sine of x, so sine of x is equal to -1/2, and sine of x is equal to 1. So we are looking for the values of x that give us -1/2. So that's the y value, remember? So right here, so 7 pi over 6 and 11 pi over 6. Same two that we had right above. And then sine x equals 1. So remember, sine is the y value, so it equals 1 right here. Remember, sine goes up and it hits 1. So at pi over 2, and then it would be 0, -1, and 0. So it's pi over 2 only. It's the only angle we get. And those are our 3 answers. Okay, so we should check these. So remember, we just have to plug them in to this equation and see if they are correct. So plugging them in the calculator, there we go. They all equal 0, which is what our equation says. So plugging the x into each of these, make sure you put a parenthesis around your sign to square it and close the parentheses. But yeah, 0, 0, 0, we're good to go. Okay, so continuing with this is the next type you're going to run into. So if you notice here, we have cosine squared and sine, and we want them all to be one trig function so that we can replace it with the letter a. So cosine squared we can use our Pythagorean identities, sine we can't. So you're going to focus on that Pythagorean identity and use it. So if you see cosine squared or sine squared, you can change them into the sine or cosine using that Pythagorean identity. So now we can distribute. Use our a equals sine x and say 2 minus 2a squared plus a equals 1. And then now we have our quadratic. So I'm going to move all of these over to the other side so that I can keep my a squared positive. So this would now be 0 equals 2a squared, because it was negative, so now it's positive. Positive a would become minus a. Positive 2 would become minus 2. And then we have a plus 1 sitting over there. So this is equal to 0, 2a squared minus a minus 1, which is exactly the same equation we have above. So we don't actually have to solve this one. We already did. So we already know after doing all the work, our x will equal 7 pi over 6, 11 pi over 6, and pi over 2. So the whole idea behind this is if you have a cosine x squared x, replace it with 1 over sine squared to get, 1 minus sine squared x to get our quadratic, which means every single trig function is the same trig function. Otherwise, we're not going to be able to replace it with a. Okay, this is our last one. So with this one, we're not going to be using the a to change things. I mean, you still can, but not exactly here. So if you look at this, you think, oh, 2 sine x cosine x. That's our double angle identity of sine 2x. But that just made it worse, because now we have cosine x and sine 2x. Now what are we going to do? So we always forget about just plain old factoring. These are still quadratic because of this. You can still think of them that way. You're still going to get 2 answers. But these both have a cosine x. So if we factor out the cosine x, we now have our factored form. So we're not going to use any a substitution here at all. We can now say that cosine x, because these are the two things that are being multiplied. So our cosine x would have to be 0, so that's 0. So that 0 times this number would equal 0. And then this one also has to be 0, so that 0 times cosine x would be 0. So those are our 2 equations. And so that one's done. This one we just have to solve. So if you want to use the a, now you can use it. We're saying that a here is sine x. So by factoring it, it allows us to put it into two linear equations. I'm going to move the 2a over. Divide by 2. So we now know our sine x equals 1/2. So there we go. So we need to know, when does cosine x equal 0? We'll start there. So when is our x equal to 0? Right there. And right there. So at pi over 2 and 3 pi over 2. And so what that means is if we plugged pi over 2 into cosine x, it would become 0. And you can easily check that one up here. So if we say that cosine of x is 0 at pi over 2, which we already knew, that would become 0. That would become 0. It doesn't even matter what sine is, because 0 times this would be 0. The whole thing is zeroed out. Same thing happens at 3 pi over 2. That's also when it equals 0, here and here. So the whole thing becomes 0. Sine is the same idea. So when does sine x equal 1/2 is what we're looking at. So it equals 1/2 at pi over 6, and then it's also going to equal 1/2 at 5 pi over 6. So those are our two answers. So why don't we check the pi over 6 and 5 pi over 6 in the calculator. And there it is. There's our answer. So what's really happening here is, if you think about it, sine of at pi over 6 is 1/2. And so we're getting 2 times 1/2, which is 1. And then that becomes 1 times cosine pi over 6. So cosine of pi over 6 minus cosine of pi over 6 is 0. That half is being used to cancel that too. But those are our answers. And so these are quadratic in form. So again, you're going to have to notice them as completing the square, like this, or factoring. And if it doesn't factor, you use quadratic formula. And then also just plain old factoring will make two different equations. So if you see cosine x, cosine x.